I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, my student has selected some difficult questions for exam practice on radian measurements. We'll work with examples based on sine and cosine law, bearing angle, sector area, and we will consider multiple triangles. I hope solution of these questions will be of benefit to you. So get ready for the exam practice on radian measurements. Our approach, engaging minds, help us to perform much better. We can now connect to context, visualize strategy, apply learnings, and bridge the gaps. Engaging minds help in creative thinking and problem solving. Gain the confidence. Get ready for future. We develop both mathematical and social skills. I can be part of your success story. Build strong foundation and ensure bright future. That is the gift of education. You can always contact me on the email address given. Join my classes. Let us now enjoy the class with Arya. Hi Arya, how are you doing?
I'm good, Anil sir. How are you?
Very good, very good. So today, what do you want to do?
I have these like extra hard questions from this website. It's called Save My Exams, which is kind of funny, I find.
Okay.
So I thought we can do some of them just so we can get an idea of like because like the word problems are really like hard to like conceptually understand sometimes with like trig. So I thought if we can do them, it would be great.
No problems. Harder the questions are, better we are, right? So,
Yep.
so it's good. You have discovered something which is good, challenging questions. Let's work on these challenging questions. You can share your screen and then let's work on them one by one.
Sure. Let me just. There we go. Alrighty. So, these are the very hard questions, and we can do the functions and graphs and the other trigonometry with the circles.
Your wish. Start from anywhere you feel like. Let's go through them. No
Sure.
problem. Right.
Let's start from here, I guess.
Sure. Can you please read the question?
Okay. Security lamp is situated at a height of 2.5 meters and positions that the central axis of the light bulb is directed perpendicularly to the horizontal. When the lamp is switched on, the light spreads out in directions of an angle of 38 degrees from the central axis of the light bulb. This information is shown in the diagram below.
Right.
Calculate the horizontal distance on the floor that is illuminated by the lamp.
Okay, so that should be very simple because you only want to find this distance, right?
Yeah.
And if I extend this particular line, so in that case, you know the height. That means in this particular case, we know two sides of a right angle triangle. Since this is a right angle triangle, correct? So let's say this is x, then that will also be x. So we can solve one triangle at a time. So let us say, let me just write A, B, C, and D, right? So what is BC and we need to find? Let it be X, correct?
Right.
So since we are looking into opposite and adjacent side, I can write that tan of 38 degrees is equal to BC over A to C, right?
Right.
And A to C is given to us, so we can find what BC is. BC
Oh,
is
is
AC
AC
times
our
tan
AC
38.
is AC just our value of like 2.5 meters because it's
Just
perpendicular?
plug it in and find the answer, please. So that is BC. However, the total distance is BD, which is twice BC. So what answer do you get? We'll multiply that by 2.
Oh.
So the question which is being classified as super hard is actually super easy.
Yeah.
So I don't think the claim is correct. I'm very frank about it. Many people claim you can actually watch my YouTube channel for better questions.
Okay.
I'm not joking. Anyway, so can you please calculate and then figure it out and we'll write down the answer.
So the height of the length of BC is 1.95 units, or it's meters.
Right. So
And
multiply
then
by 2.
you multiply that by 2, which gets you your BD, right?
Yes, yes.
So that is just 3.9064, and we can just
90, right?
90, yeah.
So normally if it is 2.5 given to you, so we can write 3.9 as the total length, right? So our answer is 3.9 meters. Is that okay?
Yes.
So that is how you should be doing it. So I think we've done the first question. Any difficulty there?
No.
So let's take up the next question.
The area illuminated is not sufficient, so the lamp is repositioned at the same height, so the central axis of the light bulb is now at an angle of 70 degrees from the horizontal. So
Okay.
here, can't
Right.
you just use Z pattern and then this would be 70 as well?
Yes, of course.
And then you just solve from there
So let's
because
read the question. Let's read the question. What do we need to find?
the horizontal, so the line adjacent to the 70 degree.
So calculate the percentage increase in the horizontal distance that is now eliminated, right? So what is
Right.
percentage increase? Can you tell me?
Um,
So that will be, so whatever new length you got, new
you multiply that by
minus the old, right?
right.
Divided by old times 100. So finding the new length, not difficult at all, right? So you have the height 2.5, the angle has been changed to 70 degrees. You need to find this distance. And from here, you can now say that tan of 70 is basically equals to 2.5 over x, right?
Yeah, and then
So we can now find that x is equal to
tan 70 over 2.5.
2.5 over tan 70, right?
Oh yeah, you just reverse
Because
it.
tan is opposite side over the adjacent.
Okay,
And
right?
since the, you know,
Yeah,
so,
oh, when you
and
bring
then
the
you
X
can
up.
calculate, right? Is that clear to you?
Yeah, that's clear.
Okay, so let's move on to the next question, please.
Okay.
Good.
These actually, well, I don't know why they call these very hard. Like,
Maybe that is the scale, I don't know what easy or medium will be. So let's not, let's move forward and let's not debate on it.
true. Okay. Okay. We can.
Yes. Yeah. Ask,
Oh,
read the
yes.
question, please.
On the diagram below, points A, -2, 11/2, and B, half and half,
Yes.
indicate the position of metal spikes called pitons that aid mountaineers as they climb. Each unit on the graph is 16 centimeters in real life.
Okay, scale
Okay.
factor is 16. Okay.
A third piton is required halfway between points A and B at point M. Calculate the distance AM.
Okay, so it is half of AB, correct?
Right,
So half of AB is you can use Pythagorean theorem, right? So
right.
A square, difference in Y values over, that will be the X square, right? So distance formula is basically what?
It's square root.
X2 minus X1 whole square plus Y2 minus Y1 whole square, correct?
Correct.
So that is how you can find the distance. And midway means distance will be divided by 2. And the scale factor is 16. So multiply that by 16, get your answer.
Okay.
So that is how you should be doing. Simple as that, correct?
Correct.
Let's move on.
Okay. Given that all pitons should be spaced at a distance calculated in part A, work out the number of pitons required on a mountain with a slope length of 25√5 meters.
Yeah, so you know the scale factor, you know that one distance, right? So you can
Yeah.
divide and get your answers.
Okay.
It's a similar triangle question, more or less. Is it okay?
Yes. Let's. Okay, let's do this one.
Sure. Yes. Please read the question.
A roof with a symmetrical triangle cross-section ABC is being designed for the top of a building. The horizontal width that the roof must span is 28 meters, and the length of the timbers used for the angled parts of the cross-section are 21 meters, as shown in the diagram. Calculate the angle CAB. Okay, so what they're saying, I think, also is that AB is 28, so that's your
This is
base.
simple right angle
This is
triangle. Drop a
cosine.
perpendicular. So the half is 14, correct? And you
Yeah.
need to find this angle, let's say theta. So it is cos of theta is equal to 14 over 21,
Can you
correct?
can
And
you not
theta equals to
also
cos inverse of 14 over 21, and you get your answer, right?
can you not also use just like your simple cosine formula and just solve for the angle?
Why should I use cosine formula? Because it is isosceles triangle. I just drop a perpendicular. I don't need a cannon to kill a bird, right? It is a simple Pythagorean theorem question, basically. So, I mean, simple right angle triangle trigonometric ratios. So once you drop a perpendicular, it is going to divide, and so theta is cos inverse 14 over 21. Correct?
Yeah.
You can find the angle. Can you please calculate cos inverse of 14 over 21? You need not simplify 14 over 21. We are only interested in theta. Correct?
Correct. 48.2.
That's it. 48.2 degrees. Done.
Okay, so an alternative design for the idea for the roof is to shorten A and C to make the apex of the roof a right angle.
Okay.
BC remains the same length as it originally was. These changes can be seen in the diagram below. The point X is situated such that it is directly beneath point C. Okay. Calculate the new length of AC.
Okay.
Yeah.
The position of C has changed. The height has not changed, right?
Right.
So let's find the height of this particular triangle. So
Just
height
B,
is what?
B sine
21,
A.
and this is 14, right? So it is
Right.
21 square minus 14 square square root, correct?
Correct.
So can you calculate that, please?
Sure. 21 squared
You can take
minus,
7 common, right?
yeah,
3 square minus 2 square square root. Yeah.
7 root 5.
Okay. 7 root 5. So let's get back to the question. We'll put 7 root 5 as the height because it is connected with the previous question, correct?
Right.
So this height is 7 root 5 as we calculated just now because height remains same, right?
Right.
Now we know that this height is this much and this can calculate. You can now calculate A to C. You could use many different ways. You can find angle B first using the right angle triangle, correct?
Right.
Because you know two heights and this is the right angle triangle here also, right? So you can first solve for angle B. Let's say sine B is equal to Cx over CB, right?
Right.
And Cx is 7 root 5 and CB is 21. So you know angle B now, which is sine inverse of 7 root 5 over 21. Perfect. Can you please find the angle B?
It's sine inverse of
7 root 5 divided by 21.
divided by 21.
Right.
Correct. It is 48.18.
48.18. So
So I
now,
think the angle stayed the same from the original. So the angle that we found for A stayed the same as the original because in the original thing it was an isosceles triangle, so the angle of A and B would be the same. So that's why our if we were to just have two angles, we could have just used sine law and then found.
yeah. So now you can definitely use sine law and find AC, correct?
Correct.
Right. So you know all the angles. You know this angle A is 90 minus 48.18. Correct? How much do you get?
41.81.
No. 90 minus 48. Yeah. How much you get? 48.18. 90 minus 48.
41.86.
86, correct. 41.86 is this angle. You can use
Correct.
sine law now to find AC, correct?
Correct.
So use sine law. So we can write AC over sine of 48.18 is equals to 21 over sine of 41 over 86. Find AC with cross multiplication. Is it okay?
That's it.
So I think we have to put the two questions together, and clearly
Yeah.
they are saying part B, right? So
Yeah.
once you move to the other screen, it becomes slightly confusing. But now I think it's absolutely clear, right?
Right.
Any doubts?
No.
Perfect. We can move on. Okay, there's another part to
And
it.
we
Part
we
C.
already calculated the vertical height CX.
Oh, of this alternative design of the roof. We calculated beforehand. Right.
We
Correct.
calculated beforehand, so
Correct.
we're ahead of the game.
Mhm.
Okay. There was. I think we can move on to the section.
Further trigonometry, take another section. Maybe there are more difficult questions. Another question,
Okay.
right?
We are very hard. Okay.
Yeah. Good.
There we go.
Yeah. Please
That's
read the question.
the diagram below shows a vertical base pyramid ABCD, where BC equals to 5.9 centimeters, AD equals to 3.7 centimeters, and AE equals to 7.4 centimeters.
Mm-hmm.
The vertex E is positioned directly above the midpoint of the base ABCD. Okay, so E is like the apex of
Right.
the polygon. And so they want us to find the size of the angle AEC. AEC. Okay, so they want us to find the angle of E right there.
AEC, right? So, yeah, so it is a 3D figure. So, it is like when you go like this, it is the vertical angle. You get the idea?
Right. So would
Vertical.
it just be so would it be like the angle of like one side plus the other side plus the other side plus the
No,
other
no,
side,
no.
angle of one side?
You can join A to C. So, you get the base. You get the idea?
Okay.
And on the base, you have this triangle now.
Oh, okay, I see. So you need to find the length of
Length of the base.
AC
And
and then find E because then you can easily find. So you have to find the length of EC and then you have AE and then
correct.
if you find AC then you can get E.
Yes. So that is how it is. So you need to find the diagonal of the base. The diagram shows rectangular base pyramid. So since it is rectangular, we know this is 90 degrees, correct?
And we
So we
know
can
that
find the base as Pythagorean theorem, which is
and
3.7 square plus 5.9 square, correct?
correct.
You have that length,
I also know that AE is equal to EC because it's
right?
rectangular, so those lines have to be like the lengths of those have to be the same.
Correct. And so it's relatively simple question. To
Yeah,
answer, you can use now cosine law. You know three sides, correct?
yeah.
And find the angle. So once you find this, you can use the cosine law and find the angle, correct?
Correct.
Okay.
I
Yes.
feel like these ones are just not worded right. So I feel like
Yeah.
if we just stick with them, it won't really work as
Correct.
well. Okay, the first one was this one.
Very good. Yeah. Can you please
So
read the question?
sure. So on the diagram below, AB is equal to 10 centimeters.
Yes.
BC equals to BD, meaning their lengths are the same at 7 centimeters. And then the angle A is 37 degrees, right there.
Okay.
They want us to find the length of CD right here.
Okay.
Sorry.
Okay.
That's
Yeah. Yeah, it's like movement. It's too difficult. So you have to find this length CD, right?
right.
Okay. So how will you figure this out with the given information?
I think at first you need to find the angle being C.
Sine law.
Yeah, using sine law.
Correct. So you first find this angle. So we'll say sine of ACB over the side opposite is 10 is
Right.
equal to Sine of 37 degrees
Yeah, over 7.
over 7, right? So
Right.
find from here cross multiply. So angle ACB is equal to what? 10 over 7 times sine of 37 degrees, correct? Yeah,
Right.
find the angle, please.
So then you have to take sine inverse.
Yes, yes.
So, and I was like, can you just write this value down so I don't lose it when I
Sure.
calculate?
So I will do this. See, first you do sine of 37 degrees.
Right.
So sine of 37 degrees equals to, then multiply by 10 and divide by 7, right?
Yes.
Times 10, divide by 7. You get some value in the calculator, which you are
Yeah.
saying is 0.859, right?
Right. And
You
then
don't
you
really have to write this value, okay? But the angle will be sine inverse of this, right?
right.
So
It's
as
just
you calculate, shift sine inverse of your answer and you get 59.28.
oh, you can leave it in your calculator while
Yes, 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 yes. You don't have to write it down. So I
Oh,
write 29. You are getting my point, right?
yeah.
So you calculate this value,
Oh,
write it here, 0.8597.
right.
Leave it on your calculator and do sine inverse.
Because it gives you an exact value then.
Yes, all decimals. Then you get a very good answer, right? So
Right.
we say angle ACB is
Is
equal to 59.2. Now here's the catch. We have to understand this part. Very critical.
okay.
You have a positive value of sine, correct? Sine could be positive in quadrant 1 and also in quadrant 2, correct?
Correct.
So you got one angle, which is approximately 59.3 degrees.
It's the ambiguous case because this can't be a acute angle, it has to be obtuse because
Yeah.
the value of
So
A
that
to B is the height.
angle is 59.29 and this angle is 180 minus that. This angle. Do you understand? Can you
Right.
see the figure now? That is the angle. That is why
That's
this
what
is a
I
very
was I was trying to do this sum today
yeah.
and I got 120.71, but I put 120.71 where you put 59.29. So that's
Yeah.
where I got confused. So you always have to look out for where your length is greater than your height because that makes two triangles, and I didn't realize that.
Yes, it's an ambiguous case, and you get
Right.
two angles. Basically, if you look at the quadrants, sine is positive in quadrant 1 and in quadrant 2. So for the same value, you actually have two solutions always. Now you have
Right.
to decide which one is which, right?
Exactly, because obviously it doesn't make sense that C would
Yes.
be an acute angle because it's shaped like an obtuse angle, and then C would be
Longest side 10 indicates that this angle has to be greater, right?
longer. Right. So
Now,
like on a test, I should always look for where my height
yes,
is greater, my length is greater than my height. Because I literally was doing this question and I couldn't get to the answer when I had the values, which annoyed me so much. Now you can just use sine.
so
Again.
that angle is an isosceles triangle. We know all the angles, correct? So third
Right.
angle is how much? Do 180 minus twice 59.3 you can do.
3 minus.
And then use sine law. Is it okay?
It is 61.4. Ah, now I understand. It didn't even take that many steps. I just had to do the. That annoyed me so much because I literally
X
couldn't get
over
it.
sine of 61.4 is equal to 7 over sine of 59.2.
3 or 290. Or
Whatever, right? So
yeah.
now you find the value of x. Is that clear to you?
Right, that's completely clear.
Yeah. Very good question. Tricky though. Since most of the students get stuck. They just put this 59 here and then they're lost. What happened?
Right, because I knew that you had to subtract 180. I just didn't realize that you had to put the 59.29 as the acute angle in the other triangle and then put 120.71 because I flipped it the other way where I put like the 120.71 in the other triangle and then my value for like C
Yeah.
was like 1 degree and I was like that doesn't make sense.
Correct.
Okay, here is the next question. Actually, did I do this question? I did do this question.
Okay.
Let
If
me
you
see.
did, very good.
It was this one.
Okay, great.
I
Awesome.
drew it out and then I just couldn't get to the value of x.
Oh, I see. Let's read the question.
Okay, So a ship travels at a bearing of 45 degrees for 12 kilometers. It then changes directions and travels X kilometers at a bearing of 150 degrees.
Mhm,
Then the ship returns to its starting point by sailing due west, a
mhm.
bearing of 270 degrees. Find the exact value of x. So what I realized is that you have to do north point and then you take 45 degrees from there for 12 kilometers.
Yes. So neat and clean diagram is very important, right?
Yeah.
So 45 degrees you are going first, and then you are traveling at a bearing of 150, right? So you go from there and then you travel. So let's try to sketch this diagram. So everywhere I try to make this kind of a coordinate, right? So
Right.
that is the starting point A for us, right? So this
Right.
is starting point A for us. And
Okay.
bearing of 0.45, bearing is always written in 3 digits as given here. So we
Right.
have 0.45 means like this, correct?
Right.
So this is 45 degrees. But when you write, you could write degrees in two places. A distance of 12 kilometers. Let's write down 12 kilometers here. 12 kilometers. Then changes the direction, travels x kilometer at a bearing of 150. So let us
You
say
go
that is a
downward.
new point for us, right? So again, I'll make a scale here. Do you see this?
Right. And you draw it northwards and then you go 150, but you go downwards because you're going below the
So 150 is 90 plus 60, right?
yeah, 60 exactly.
So
And so
that
with
this is
bearings on
30,
90 is our x-axis and then you're going
so that is
vertical.
30 degrees. Do you see that? This is
Right.
150 degrees. Do you see how we label the angles? Correct. That is 45. This is also 45. Do you see how I'm getting all the angles so easily? So we
Yeah.
have the vertex angle, which is 45 plus 30. You get the idea.
Right.
Now it says changes the direction and travels x kilometers. Let's write x here. At a bearing of 150 degrees as shown, the ship then returns to its starting point by sailing due west. So due west means
You're
it is
going
actually hitting this line. Do you understand?
right.
It is only then it goes due west. Due west means 270 as they are rightly pointing out, right? Do you see this 90? 90 and 90. Is it okay?
Yes.
So that is the meaning of 270. So it hits the original horizontal line. So you formed a triangle in which one side is 12, the angle in between is 45 plus 30, and third side you have to figure out. But you also know this side because this is also 45. You get the idea.
I
Because
see.
it makes a right angle triangle. So
Ex-
now you know
So
two sides and an angle in between.
so
I mean, two
same
angles in the side, correct?
I got the same what is it called? The diagram as you.
Yes.
But what my question was that if you have your angle in the middle, obviously you're trying to find the distance from A to the point of where you were at 270.
Yes.
So my question is that you can't use cosine law, can you? Because you don't
Find the
know what
third angle. Find the third angle.
the third
180
angle.
minus 45 minus this sum, which is 45 minus 75, right? 45 plus 30. How much do you get?
You get 60.
So this angle is 60 degrees, correct? Now
Okay.
you can apply the sine law.
I see.
Get the idea?
Okay. Yeah, because then you can go 45, sine 45 over x equals to sine 60 over 45, and then you just go from there. Okay,
Easy.
that's what I was missing. Because
Yeah.
what I assumed is that because we have the bearing of 270, you could have just gone 360 minus 270 to get that angle, but you can't do that.
Hmm.
It's you don't know how much of the angle is actually proportional to the 360.
Right. Here you can use special triangles to calculate. You get the idea? So
I
this
love
question
special
could come.
triangles.
This question could come without calculator also. Sometimes in IB, you have questions without calculator. So this could come without calculator.
It's right here.
Right? So we have 1 to square root 3,
Right.
60 degrees, correct? And you know, what is sine of 45? Sine of 45 is 1 over square root 2, or you can
Right.
write square root 2 over 2.
Square-
And
square-
sine of 60 degrees, sine of 60 is square root 3 over 2, right?
Right.
Square root 3 comes here and 2 goes here. Now you can calculate this, correct?
Correct.
24 over square root 6. Calculate this.
4 root 6, which is one of our options right here.
Perfect. So
Perfect.
that is how you're going to solve this question. Perfect.
Perfect.
Very good question.
Okay. Okay, let's do this one.
Sure.
In the figure shown, O is the center of the circle and AG is a tangent to the circle.
Correct.
Given the radius of the circle is 4 centimeters and the length of the tangent is 9 centimeters, find the area shaded.
Correct. So find the area of the triangle first and the sector area. So two things you have to find. Correct?
Right.
So how will you do it?
So you don't have the value of the angle, so you can't just go half AB sine C. So you need to find the angle of A. So
No,
that
you know the area of the big triangle because tangent is at right angles, correct?
right.
So area of the triangle AOB
Oh,
is half of base, which is 4, times
4
9,
9
okay? Which is
times
18.
and sine of 90 is just 1. Oh, okay, so that's what I didn't know. So I didn't know tangents lines create a right angle, which means that it's at.
Oh, yeah. So,
Okay.
and you know this is Pythagorean theorem, right? So, 9 square plus 4 square square root, right? The whole length, 9 square plus 4 square square.
81 plus 16 square root is just.
Yes. How much do you get? Less than 10 of it, right? 9 point something.
It's like 9.84.
Correct. So, you know the total length, right?
Right.
So, now you can actually find this angle. Not a problem, right? You could find
Right.
this angle even otherwise. You don't have to do all that. Because
Right.
you have a right angle triangle, right?
Right.
And in this particular right angle triangle, you can find the angle because you know the opposite and the adjacent side. So tan of
Tan
the angle
theta.
AOB
Right.
is equal to 9 over 4. So angle AOB is tan inverse of 9 over 4. Correct?
Correct.
Find it out, please.
So one thing, whenever they say tangent, you should know that always a right angle is formed. So then you can use your
Yeah,
part
yeah, of course, of course. Yes.
Okay. See, that's the reason why I didn't know how to solve it, because I was like, how do I know where to find the angle if there is not another angle given?
Oh, I see. Now it is clear to you, right?
Completely clear. See, I
Very
did, as you can see in the blue, I did all these other questions. I just didn't know how to do the tangent ones.
Yeah,
It's
yeah.
66.03.
Good. So now you know it. So you can move forward with this, correct?
I can do then you just have to, you know, the area of the triangle, and then you find the area of the whole sector, and then you just subtract them to find the area of the segment.
Perfect.
Simple.
Very good.
Okay. Oh yeah, this one was very difficult for me.
Ask. Read the question, please.
The diagram shows an outer circle of radius 8 centimeters and an inner circle of radius 5 centimeters. Both circles have the same center, so the center being this. Find the perimeter of the shaded region.
Oh, basically, see, you have to find this length is 3, you know, right?
Right.
8, 5, and 3, correct? Now you have to find arc length, which is r theta, right?
Right.
So I will convert degrees to radians so that we can directly find the angle. So let's say theta in radians is how much?
Pi equals 180, so 140
Oh.
times pi divided by 180.
So when we have 140 degrees, we want radians. That means we want pi on top. So think like this and divide by 180 because pi and 180 are same things.
Right.
Degree cancel. You are left with radians. So
Right.
how much in radians this angle is?
7 over 9 radians. 7 over 9 pi. Sorry.
Pi is in the numerator.
7 pi over 9.
Okay, that's what I was thinking. Like, what happened? Okay.
I
So,
just did that very
oh, you,
quickly.
you just divided by, okay, common factor, right? So,
Yeah.
220 basically. So, okay, 7 pi over 9. Makes sense.
Right.
So, now you know these two arc lengths, right? Which are r theta, right? So,
Right.
one of them is, outer one is 8. 8 is the radius. And theta means 7 pi by 9. Is it okay?
Right.
And the lower one is 5, 7 pi by 9. Is that correct? Add
Oh,
these two and add 6 because 3 and 3.
right.
That's how
I
you
don't.
get the whole perimeter.
So my question is, why did you do 8? Is it because this radius length here is just 5 plus 3?
8, yeah. 8 because it's given 8, right?
Right.
Outer radius is given to you. I split that 8 into
Oh,
5
okay. So this is the outer circle, then the inner circle is your
5.
5. That's why you
Very
have to do 5 times 7 pi over 9, and then you have to add the inner the shaded segments,
correct,
3 and 3 radius.
correct, correct.
So then that gives you the perimeter because you're adding it all up.
Perfect,
It,
perfect.
they're just asking for this segment right here, right? The
Yes,
segment right here. That's all they're asking.
shaded area. Shaded area.
Okay.
Between two circles.
Okay, now that we know how to do that, I think I can do this one because
You're right. You can do this.
I
Very
can
good.
do yeah,
Perimeter, you have to find your arc length A equals to r theta and then. Very good.
yeah, I can
Yes.
do that. Okay. Shall we do this one?
Your wish.
Okay.
I'm
Find
in
the
for it. Yeah.
find the area of the major sector in the figure below.
This sector.
So
Correct?
I think it's yeah. So the major sector is that, and I know that you would
Find the
have to
angle.
you'd
So
have to find
angle
the
is 1
whole
radian. Do you see the angle? Because you see the this is an equilateral triangle, 60 degrees, not 1 radian, but 60 degrees. Correct? Theta is 60 degrees. Do you see that?
Why would it be 60?
Because it's an equilateral triangle, 1, 1, and 1.
Oh, okay, yeah, I see that. Oh yeah, because
So this angle is basically 300 degrees. Is that okay?
right.
You could also, when you are finding area, so you can use degrees also. You get me? Area, total area of the circle is what? Area, let me say, area of the circle is how much? Pi r square, right?
Pi squared,
Pi
right.
times 1 square. Okay, so it is pi, correct?
Correct.
Now, bigger area, you can say pi times 300 is the angle, divide by 60. Because this is your major sector, what do you get?
So what I would do is you have to just find the area of the sector over here, the minor sector. So you know that the formula is half r squared theta.
And theta is 60 degrees, which is 60 degrees pi by 3, correct?
Right. So then you
So
know radius is
half
just the
1
half
square
by
times pi by 3, correct? So which you get pi by 6, correct?
correct.
Okay. And total area is pi r square.
Exactly. So pi r squared is just pi. So then you just go pi minus pi over
Yeah.
6.
So you get 5 pi by 6.
And then there's your answer. 5 pi by 6.
Correct. That's correct.
Okay, this one I was so confused because they're giving you the area and then they give you the arc length, but they didn't give you
Oh,
any angle or
yeah.
radius.
Arya, we
Yeah.
could have got this. Let's go back to the question. We could have got this last time. I don't know what calculation mistake we did. We could have got it straight also. Let me just show you that.
Which one was it?
The last question, that area.
No, where did it go? Okay, ah, here. No, where is it? Where did it go?
Mhm.
Oh my
Yeah.
goodness. Oh, I'm sorry, I don't know where it went. Okay, no, no, no. Yeah,
Yeah.
there we go.
Look here. The whole circle is pi r square, right?
Right,
Pi r square full circle, right? R square is the full circle times this is bigger angle of 300 degrees, right?
right.
And the total was 360. So it is 300 over 360. So we get the area of the major sector. You see how straight away we got it?
Oh,
So 0, 0 cancel and 6 goes 5 times. So 5 over 6, 5. R is 1.
right.
That is how we'll do it. So that is what we wanted to do.
Okay, see, I just realized why I got 60 is because for the full circle to occur, it has to be
Yeah, we
360.
should have taken 360.
300.
Full circle. Full
Okay,
area is 360 degrees and the
right.
partial area is 300 degrees. So many times you can actually solve the question without even converting to radians. You get the idea?
Right.
because of infinite symmetry of circle.
It's just continuous and it's symmetrical.
Very important point because it really saves a lot of time in many questions, and that is critical.
Right.
Okay.
Okay.
Yeah, let's move forward.
This is the tangent one, and now I realize the tangent
can do it easily.
degree, so I can do this one.
See, the diagrams are confusing because diagrams are not to the scale, so it doesn't look like a 90 degree. Get the idea? They purposely make it like this.
I see.
So that it doesn't look like 90 degrees. That's the problem.
Okay, just I know now. Just when it says tangent, just know it's a 90 degree.
Yes.
From there. So okay, so here it just says segments AC and AD are tangents to the circle centered at F. So I think I know that this is 90 and this is 90, and I think I can solve from there.
Very good.
Right? Okay.
No problem.
I think we should do this though, just in case, just so that.
Okay, sure. Yeah. Please read the question.
In the figure below, the large circle centered at A has a radius of 4 centimeters, and the small circle centered at F has a radius of 1 centimeter. Okay. Segments AC and AD are tangents to the circle centered at F. So this is a tangent, and this is a tangent. So this gives you 90 degree, and this gives you 90 degree.
Yes. Now what else?
And then the F has a radius, the circle F has a radius of 1 centimeter. So they want us to find the area of the shaded triangular region minus the circle.
Right. So in this particular case, you need to find the area of the center circle is clear to you, the small circle. The small circle area is pi r square, right? Pi r square, which is pi, right? Because r is 1. Let's say small circle. Is it okay?
Right.
So you have to take away that area from the sector area of ACD. Right. Now, to find the sector area of ACD, you need to find the angle in the center, correct?
Correct.
Now, you know these are tangent as you just rightly pointed out. And this length is how much? A to F is 4 minus 1, 3.
Okay.
So now you know 3 and 1 are the two sides, and therefore you can find this angle. This angle is opposite of 1 and 3 is this. So tan of, let's say theta by 2, let's say this angle is half of, right? Tan of theta by 2 is basically equal to 1 over 3. So half of that angle in the center is tan inverse of 1 over 3. Can you calculate this?
Why did we go theta by 2? Is it because the angle is separated into half?
I'm using this also theta by 2, this also theta by 2, right? So the total angle will be theta for me.
Okay.
You could take theta and then multiply by 2. That's okay.
Okay. So that's it's 18.43.
Multiply by 2 to get the central angle.
36.86.
36.86. And now we know the center angle, and r theta, half r square theta is the sector area.
Right. And we know that
r square theta. Calculate this, please.
So it's r squared, which is 4 squared, times our theta, which is 36.86.
No, you have to do it in radians. Sorry, my dear.
Oh, yeah.
Calculate the angle in radians, okay? You use calculator in radians, please, and convert this to not in degrees, but in radians.
Okay.
It's easy, better.
And so,
yeah.
Wait. If I put my calculator in radians, would it just change the value automatically?
Yeah, it will change the value. Redo. Just calculate change mode to 4, which is radians, correct? And then do shift tan inverse of 1 over 3. 1 divided by 3. In radians, you get half angle as 0.321. So in radians, it is 0.32175. Now multiply by 2 because you get theta, which is 0.643. So this angle is 0.6435. Is it okay? Use calculator as such. Don't change it. Okay. So half r square theta, multiply by half of, so multiply by 16,
Okay,
divide
half.
by 2.
Okay, so 616 times 0.6435 divided by 2 is 5.148.
Check your answers, see if you have that option. Minus, sorry, minus this pi, because you have to take away this, right?
Oh, yes.
And take away the radius, which is pi r square, which is pi. Take away pi from here.
Minus
Right?
5. I got 2.006. I'm
So
not
it
sure
is
if you
2. Do you have that option?
Yeah, I got 2.
Okay. So remember, you have to take away the area of small circle, right?
Yeah.
So Aryan, we'll actually close here.
Okay.
You can stop sharing. Can you revise? What did you learn today?
So I learned that when they say tangent, you always know that it's 90-degree angle that is being formed. Whenever they're asking for like the area of the shaded, you need to find the area of like the whole sector and then subtract that from the area of the triangle or the circle, whatever they've given you.
Yes.
And the area of a circle is pi r squared. So if they give you the radius, you can just do pi times the radius, and that'll give you the area of the circle. And then if they give you like the major circle and they want you to find like the major circle's area, and then they give you like the minor sector, then you just take the major sector, which is pi r squared, take its radius, and then subtract it by the minor sector. And then know that your drawing should be very accurate. So just make sure to do that. And also look out for the ambiguous case. So if your like height is smaller than your actual length, then you have an ambiguous case and you make two triangles, and just know like which one should like by vision and also like by like common sense should be like your obtuse one versus your cute one, because if you're like me, then you'll find out that one of your angles is 1 degrees, and that makes zero sense.
Okay, so we'll end the class here. Feel free to ask any questions. Okay.
Yep.
Bye for now. All the best.
Thank you.
Bye. You can always join my classes by writing to me on the email address given. I can be part of your success story and build strong foundation to ensure bright future.